The last piece of what we're going to do here is show you where the formula you learned in the video notes for the sum of a geometric series actually came from. It's a really cool little trick. So first what we're going to do is write out the terms of a geometric series. First term is a1. The next term is a1 times r. The next term is a1 times r squared, because each time we add a new term, we just multiply by r one more time. So by the time we get to the end here, we just keep adding, adding, adding. By the time we get to the end here, our last term is a1 times r to the n minus 1. However many terms there are, we've only multiplied by r one fewer than that. Because if we're on like our 30th term, it means we had the first term, which we didn't need an r to get, and then we multiplied by r one more time to get each of the next 29 terms. Well, and then the term before that would have been a1 times r to the n minus 2, and so on. Okay. I'm going to also take the same series, s sub n, and multiply every term by r, because I want to. So the first term isn't just going to be plain old a1, it's going to be a1 times r. So let me write that out. Now I'm going to line that up under the other a1 times r. Notice how it's the first term, which is why it's the first one on this row, but I moved it over to line up my like terms. The next one would be a1 times r squared, because I had an r to begin with, and then I needed to multiply by one other r to get to the second term, and then so on, so on, so on. Notice how this time our first term had an r in it, so our 30th term, or our nth term, will have that one original r plus n minus 1 more r's. So that'll be a total of a1 times r to the nth. And the term before that would have been a1 times r to the n minus 1. So the second to last term would have the n minus 1 in the exponent. And the third to last term would be a1 times r to the n minus 2. Now here's where the fun part comes in. What I'm going to do is subtract r times s sub n from plain old s sub n. And on the left-hand side, those aren't like terms. I can't really combine them. That's s sub n minus r times s sub n equals. On the right-hand side, this is where the fun happens. Notice how every single one of these rows, these columns that I've actually lined up, if I subtract the bottom one from the top one, there'd be nothing left. a1 times r minus a1 times r, a1 times r squared minus a1 times r squared, and that would keep happening for every single pair of terms except the first term, a1, which didn't have a pair to kind of subtract from it, and the last term, a1 times r to the n, which I'm sorry would be negative because I'm subtracting, so this will all be subtracted. And so my weird expression, which you possibly can't imagine why I care about, s sub n minus r times s sub n, but it is equal to a nice and simple a sub 1 minus a sub 1 times r to the nth. Now remember, our goal here was to find a formula for s sub n. So what I'm going to do is solve this for s sub n, which doesn't take a lot of work from here. All I need to do is look at this left-hand side and say, oh, there's an s sub n in both of those terms. I can factor it out, just like we did with our log equations in the last unit. If we factor out the thing we're looking for, it doesn't really matter how weird the other piece is. In this case, it would be left with 1 minus r. It's going to be very easy to solve for s sub n, because all I have to do is divide by 1 minus r. And this is where the formula for the sum of a geometric series comes from. And while I'm at it, I might as well factor out the a1 from the numerator too. So you'll see it in a way that you recognize from the video.